Waiting for the record button to come on. I don't see it yet. Or now it's on. Okay. So welcome to this, I think, fourth session, if I don't misremember, to cover different parts of Project E. So today's topic is about the volume management side of things. So the way this stuff is structured is, looking at it from an Eve perspective. Yes, these things actually get exposed. This functionality gets exposed through the UI and the controller. So I think it's sort of fair game to phrase questions from the perspective of what you see in the controller. And I've tried to sort of capture some of the terminology differences between them. But since this is more about the open source side of things, the details of, okay, exactly what does it look in the UI is actually not core to this stuff. But as I said, the concepts, the objects you operate on, whatever, show up through the controller. So just as a background, right, this is what you guys asked us to talk about. The aspects about volume management and images and image creation, and about best practices in terms of how to use these tools with focus on virtual machines. I will cover a bit, since we support, container format, OCI format. I'll talk some about that as well to make sure that we cover that part of the system, even if the people on this call aren't using that today. So any questions on the scope so far? And please feel free to interject, even make this as interactive as possible.
Yeah, Eric, just to mention, I think this is actually part 3. Yeah, we haven't had this is the part 3 session.
Yeah, I was looking through them and I thought that we had we didn't have the hardware one yet. Okay, because it was in my recording. But okay, or in my notes, so I can go update this stuff. So thank you. So volume management. So the volume management, when you first approach it, and actually when we started, it was rather simple in that, well, at some level, you just say, I want to deploy this virtual machine using this image, and like, what's to that? Well, it turns out that over time, we realized that actually having some deeper level of the structure here is actually quite useful, because it gives us flexibility in terms of reuse, in terms of updates and whatever. So the sort of multiple layers of this picture, right, there's basically 4 layers in this picture. So we start with something that is a data store, which is basically a place and where you fetch the actual content, and it might have some credentials as part of that. And fundamentally, what you actually describe, what you tell Eve, what you tell the controller is metadata associated with that place. So it's like the URL, path name, where to go fetch things, and the credentials, and things like that. And we support today is several different ones. There's Azure, AWS S3, HTTP, HTTPS, as well as the sort of OCI protocol and manifests associated with getting content from Docker Hub, etc. And feel free to ask questions about it if you want me to explain more about this. I decided not to do sort of a full slide going into all of the details of these different concepts, but I can definitely expand on it if people want to find out more. And then the next level was basically separating out, or basically being able to specify a particular object that we download from the data store. And this, we call it a content tree, or an immutable volume. But it's basically, in its general form, it's actually a tree. So this enables you to leverage things like layered content, like what is available with OCI manifests. but it's something that is uniquely identified by a hash of the top of the tree. And this is actually something that's used inside Eve to then say, as we download this thing, we are actually storing it as content addressable storage, meaning anybody that knows the hash of this thing can go fetch it within Eve. And this is one of the pieces that enables sort of reuse of different components, right? Different content. The fact that it's a tree, the thing that it doesn't show on this list, which is actually visible in the API, is that, yeah, the tree, when it has multiple parts, it's actually those parts in Eve, we call them blobs, but it's basically, in Docker parlance, it's actually the different layers of the content. And those are actually the things that get stored into CAS, and you can pull that stuff from anywhere, you know, the different layers get reused, but you're always pulling it from the top of some tree that references a bunch of things, leaves underneath it. But what's important, even as we do things with VM images, these things are also represented as a tree. The tree is actually fundamentally, it's one piece there. We have to keep track of things, there is actually a manifest that sits on it. So it's actually a tree of depth too. And then, but now we actually have managed to download some things that is actually immutable, right? And then what do we do with this? Well, the normal thing is that you actually want to, at some point in time, have an application use this, and then you create a volume, also known as block storage, also known as immutable volume. So these are typically read-write constructs that are presented then to an application in the form of a virtual disk. So an application can access one or be configured to use, you know, one or more virtual disks. They can be accessed through different mechanisms, through the hypervisor in terms of quote unquote protocol or whatever we should call it, right? But that's something that's transparent to an application developer. It's just something that's between the actual guest virtual machine and the underlying support on the Eve side in terms of presenting this data. So are these concepts sort of reasonably clear to people, and do they make sense? I'll take that as a yes, even if it's quiet. So the thing that, you know, we didn't, when we started, right? We had images, we had data storage, we had images, and then drives. Right? So these additional layers with content trees and volumes is something that was actually added as we went along to enable better use and better management of this stuff, being able to explicitly sort of pre-provision things. If you know in the factory that this thing is going to be deployed out in the field where I have limited bandwidth, and I know that I might want to use all of these, you know, a dozen different apps, and I have a big enough disk, well, I can preload all of those in the form of content trees. And whether I use them or not, well, that can be decided later. But with this structure, and we have that possibility, right? The existence of the content and the volumes is not a function of the apps actually being deployed at the same time.
I have a quick question. What is there a most common approach, or do specific accounts tend to use the same approach for all their volumes, or is it really based on what the application is most apt to, you know, be useful for it? Is like, do you choose based on the application needs, or do you choose based on some other?
Yeah. I think we see a couple of different sort of usage patterns in terms of people might have, for instance, as I said, you know, a hardware manufacturer. It's not something that we've seen directly, but sort of like if they don't know whether you're going to run Windows or Ubuntu or CentOS, right? Well, they can actually create content trees for those things in the factory, right? And they're just sitting there ready to be used, right? The one that we do see is more that there is some potentially large content that you don't want to download to the edge on the fly because it's sort of raw static, right? And it's sort of like a pre-populated data disk. So that's one of the use cases that we'll cover. later in this presentation on how this stuff fits in with that. And in some cases, this could be huge, meaning that if you were to deploy that at the edge and just try to download on the fly, it might take a week to download. And then sort of how do you actually structure this stuff? How do you leverage these concepts to make sure that you get sort of flexible ways of managing it and being able to update pieces independently? That's something that we'll cover later in this presentation. But yeah, as I said, right, the way we look at this stuff and the way it's exposed in the commercial controller today, the Solidity commercial controller, is that some of this stuff ends up happening implicitly, that you just specify as part of deploying an app instance that I want to use this image. Well, it actually ends up creating the content tree and the volume to go with that, right? So these things end up being implicitly done on the controller. That's not something that makes any difference on the Eve side. Right? But when they are implicit, it gets hard to tell, okay, what is the actual virtual disk volume and content tree in this picture? Because it all sort of looks the same. If the content is a VM image, well then the virtual disk is identical to the image as well, right? Like, but we'll look at how this stuff is actually useful to separate. There's some other options that you can have as part of creating volumes. One is you want the volume to remain encrypted on the disk, or clear text to get slightly better performance. And we also have support for creating read-only volumes. The intent is that, you know, if you have some data content and you want read-only data, multiple VMs, app instances should be able to share that in a read-only manner. And some of these things become easier if we're exposing that stuff not as actually virtual disk, but as a file system, using a file system protocol, which is what Eve does today. When you're deploying containers, things are exposed as file systems. But keep in mind that the content trees are always shared, right, to the maximum extent possible. So if you look at the sort of normal flow, right, in terms of the mechanism happening on the Eve side, Eve sees some content tree specified in the API. And if this is a VM image, which it can tell from the type of the content from sort of an HTTP or whatever protocol that's providing it, it says, okay, I should actually create a manifest to wrap this thing so I can actually keep track of it the same way and load it into CAS. And otherwise, it recursively traverses the manifest and downloads and verifies each blob, each layer in this tree. And once they become verified, this thing is actually loaded into the content addressable storage, which is implemented using Containerd. You can actually go look at what is actually there if you get SSH into Eve in a debug setting. It's in /persist/containerd. And then Eve handles the volume config specified in the API, which typically shows up at the same time, but when it boots and finds all of this stuff, or when you deploy an app. And each volume references some content tree specified by UUID. So these things here, in terms of Eve interacting with things, they operate by UUIDs. When you're looking at things in the controller, the stuff might be in the form of names or tags or whatever to keep track of the reference. So the volume, once the actual content has been loaded into CAS, the content tree will be used to create a volume. And if this is a VM image, it's basically just performing a copy. If it's a OCI image, it actually does a snapshot and basically lays down things based on the hierarchy, the layers on top of each other. and this then gets created. It's in, again, if you're in a debug setting SSH into Eve, you can look at it in persist vault volumes and in persist clear volumes, depending on whether it's encrypted or not. Then Eve, again, this all happens at the same time that it actually gets an app instance config. And that has one or more volume references. Again, it's a UID that refers to the actual volumes it wants. And once the app instance sees that all of these volumes are created, the actual virtual machine or container task is booted. So that's sort of the normal flow that you see. And yes, when you do this, I can pre-download content. Well, in that case, E will only receive the content tree up front, or I want to pre-create a data volume with all of this useful data for my application. Well, you would actually see a content tree in the volume, and then at some later point in time, there might be an application coming in referencing it. So any questions so far? So the other thing that happens with volumes is that you might want to update things or revert things. So there's this operation exposed in the API as well as in the Solida controller that called Purge. So that means basically replacing one or more app disks with a fresh volume. And what does fresh mean here? Well, it means it was actually newly created. It wasn't what you were using before. And there's two ways this is actually used. One is, you want to revert to the original content. Like you were tinkering around with some, VM image running Ubuntu, and you basically screwed up and you deleted half of the root file system. Well, you can actually just tell using the purge operation, you can say, just go back to that content that you generated from the beginning, and now the device will actually be rebooted with a fresh volume. No history whatsoever retained, right? And the other use case for this is saying that, no, I'm actually running, but if this is the root disk, I'm running Ubuntu 16.04 and I want to move to 18.04. So I can actually point the root virtual disk of this to refer to this content as something different. And in that case, the app will at some point in time be restarted with that disk plus any other virtual disks. So this purge workflow is actually done to minimize the outage for the application. And this is sort of dealing with the edge where, you don't actually know how long time it will take to download these applications, right? These images. If you need to have a new version of the image, the content, maybe that downloads in a minute, maybe it takes a day, right? So, and the flow inside Eve is checking that whether the content already exists in the content addressable storage. Otherwise, it does download, verifying, and loading into CAS as in the normal sort of starting case. And only when this has happened, it says, I have content, I can now create a new virtual disk, and then halt the application and reboot it using the new virtual disk or set of virtual disks.
So quick question here. Is there a mechanism to have it, because it looks like it once it verifies that the volumes are available, it immediately, does the purge. Is there a way to have it wait to be explicit to explicitly make that happen, or because the issue here is that you could have something working in the field, right, and it's an active job is running, and if it has to make this go through the step without any explicit instruction, you could mess up a job. So is there a way to actually have it wait for a user to
So in principle, right, and I don't think if we verify this stuff with sort of the explicit explicitly tag content trees, but in principle, right, and Eve can definitely do that, saying that, okay, I know that here's a new version, create a content tree for that, and then, that's configured into Eve, it does the download and verification, right? And you can actually see in the UI that, okay, this stuff actually made it there, right? It's correctly downloaded and verified. So then later you can press the button saying, okay, go use this thing. I don't think we've tested that one in terms of, okay, what does this look like in terms of the tags that are used in the UI to refer to this thing across with a purge. So there might be some things there that would need to be tweaked, but I don't know if anybody on the call has actually explored this thing. But
Eric, in today's workflow, what the question is, we are answered. That particular workflow is available for Eve images, where we can separately download Eve images and then install them at user maintenance windows and on a scheduled time, right? So you download it as a separate action and then install it as a separate action. For a purge workflow, we are currently exposing one action where a user can choose. Let's say you have 10 applications that are deployed that all need a upgrade or a purge action. So the user can now choose to hit that purge button or send that API request at any time during the maintenance window they can do that at separate times for all those 10 applications. But in today's implementation, we do not have a two-level action where you can say, I'm going to first download everything, even for the application volumes, and then purge them later. That is not available today. But as you said, there is no reason for it to be present in the future.
Yeah, it's there in the Eve API. It's more about the UI workflow. Right?
Thanks.
And then the last part of the sort of main workflows is what happens when you actually delete things. Well, so if you delete an app instance, it means that all of the app instances references on its volumes are dropped. And this means that on Eve, it's all based on reference counts, this thing, right? But the actual behavior you see is a combination of what Eve does and what the controller does. So if you have implicit volumes, the controller, as part of saying, oh, I'm deleting this app instance, is also going to go ahead and delete the volumes and the content trees that are used exclusively by that app instance. So Eve will actually see a delete of all three objects. So that will actually trickle through the microservices in Eve, and it will actually end up with 0 ref counts on the volume and 0 ref count on the content tree. So that actually means that there will actually be deleted. The space on disk will actually be made available. When you have explicit volumes, well, now the controller and the UI actually is where you go do this stuff. So you would actually go in there and say, no, I'm gonna delete this object, right? So the app instance, if the app instance has a mixture of implicit and explicit volumes, well, yes, it will take with it on delete. It will take with it the implicit ones, but not the explicit ones. So what about security of this content? So there's several different layers for this, right? In terms of the actual images, right, the actual content. Well, the controller might provide two different mechanisms to hand content to it. One is when you actually do an upload operation where the content actually passes through the controller, and the controller can now calculate things like the SHA and the size of the content, and then saving it in S3 or sort of whatever. And the other way of doing it is when the content lives somewhere else, like in your local HTTP server or in Docker Hub or somewhere. where there's some uplink-like operation in the controller where the user gets to specify the SHA and size of the content. And the metadata gets stored in the controller. And then once you have this, well, is the image actually signed? Well, the image isn't signed per se because we have the SHA, and the SHA actually gets signed as part of the whole configuration that gets sent to the device. So I don't know how familiar people are with how signatures actually work in practice, right? But you can actually say, I can do a signature of a gigabyte document. Well, that actually consists of 2 steps. In some APIs, like in Python, it's hidden behind the APIs. You don't know what's going on. But you basically first end up creating a SHA of that 1 gigabyte thing. And now you have 256 bytes of SHA. And that's actually what you're signing using public key crypto. So this is basically the same thing, that it's actually split, right? That the SHA is either provided or generated, and then the actual that is actually signed as part of providing the whole config to Eve. And the way this is, there's a link here to the fact that we actually do object signing. We don't only rely on TLS for the security of this stuff. We actually explicitly sign the objects. The API allows for separately signing of the SHA as well, but we found that this stuff is actually quite complicated to use because people need to provide and maintain the complete certificate hierarchy used to validating those signatures, which is dealing with certificates and refresh renewals of those things is actually quite complicated. So it's not actually exposed in the UI in the commercial controller today. So we had it there earlier. So this stuff doesn't actually, as I said, the security of this, yes, you can download this thing over S3 or Azure's blob storage protocol or HTTPS or whatever. But fundamentally, the security of that with TLS, yeah, it means you're not talking to the completely wrong server typically. But the security of the actual image, the actual content that you end up using doesn't actually depend on that. Right? You could, in theory, get the stuff through a completely insecure mechanism. You could just run, whatever. Get it from a device sitting next to you in principle, right? That happens to have that content. Do you know if it's the right content? No, you don't. But you will actually verify it by looking at the SHA of that object once you have received it. One note finally on for OCI images, where sort of in the world of Docker, there's a bit more flexibility that as a developer, it's often convenient to refer to something with a tag like :latest, saying, I want the latest version of Nginx, I don't actually care. Or I want, the 2.0 release of it or whatever, right? But I don't actually care about the details. As well as there's a way of saying, no, I want exactly this SHA of this of this content, and this is basically in the URLs that you use with Docker with OCI images. So if you have a fully specified SHA and in that name, yes, now that top level SHA will be verified as well. But you can operate in this mode where I'm just using latest, and because I'm running the stuff as tests. And maybe once I've tested it, I determine what SHA was used, and that's the one that I know works. So I'm now going to use that, pre-specify that SHA when I go and deploy. Right. So this is sort of a trade-off between developer ease running through the test cycle, and then saying, okay, as part of that, I have now nailed down the SHA, and this is what I'm using in this deployment. So next one. So there's also a layer of security on the volumes themselves, right? And the user has the ability to decide whether the volume itself or its content should actually be encrypted or not. So in the API, there's a field called clear text. In the controller, this is probably exposed as an encrypted setting, right? That you can click on or not. And if you set it as clear text, you might see slightly better storage performance if you have applications that are very data intensive. I think there's been cases when people have seen a 10% difference in terms of storage benchmarks. But if it's kept in the vault, right, then encrypted, that means that the content is actually locked to the device, and it goes back to the hardware root of trust in the TPM. So it's impossible to decrypt this thing on any other device. Furthermore, in terms of the measured boot and remote attestation, which I think we covered in the overview, right? If the firmware or EOS or anything else changed as part of the measurements, it means that the vault cannot be opened until there's been a remote attestation exchange with the controller. So this is using the standard TPM measured boot mechanism, but it means if somebody puts in a bogus BIOS or whatever, or manually changes Eve on the disk by taking out the disk or whatever and putting something else on it, yeah, the controller would presumably say no, saying that's not a valid remote attestation chain, or sorry, PCR extension chain. These PCR values is not something I ever seen before. You can't actually access the disk. So there's this trade-off, right? If you put it in clear text, it means that if I take out the SSD, I could actually go read what's inside that volume. So that's the state on volume security. Any other security questions that come up in the context of volumes and images? Okay. So the actual images that get used for volumes, there's a choice between basically using existing things out there and creating them. Right? And one thing that we see people doing is actually using Cloud-init enabled images directly. So there's VM images, you can just go run them. So the way we've done this when we've tested it is that you create some data store that points at the cloud images for Ubuntu and the releases path, so you have a stable path hopefully. And then you, as part of specifying an actual image, you have to figure out what is the actual SHA and size of that image, and then you can go and specify that image, add that to the set of images in the controller. And when people do this, it's normally the case that you use Cloud-init, right? The user data that you specify in the controller to do the configuration. So now you can set up any accounts, any additional packages you want to add to this thing as part of its initial boot. So these is a flexible way. Right? There's similar things you can actually do with OCI, where you just say, oh, I want to run this MQTT relay or Nginx or whatever. Right? You can just refer to that, creating a data store specification that refers to hub.docker.com or your local OCI conformant registry. But in many cases, people also say, well, no, I'm going to create my own custom images. For that, we support QCOV2 and raw format. QCOV2 is better for volumes that grow over time, because you don't have to send across all of the bits to make up the actual volume. You say this is a 10 gigabyte disk, but it's only populated with 500 meg, because that's what sits there by default, the sort of operating system or whatever might be there. As opposed to raw, you end up laying down all of the bits. If you have other formats, we discussed about having Eve actually do that conversion, but it's actually not very efficient because you end up doing that on every device and it costs both CPU and storage. So, you basically do the conversion before you go and upload them. I have some more stuff on that on subsequent slide. But we found that this sort of provides sufficient flexibility to do different forms of images when it comes to getting the content in the system.
Eric, one quick addition to that QCOW2 images. I mean, some of our customers actually have constrained devices where the storage of that QCOW2 would also be an issue. And QCOW2 tends to be a little larger than VMDKs that ESXi uses by default. So if instead of QCOW2, you can actually use compressed QCOW2, which is not exactly same as VMDKs, but very close to VMDKs. It comes down to very close to VMDKs. And Eve actually processes compressed QCOW2 directly. So you do not have to do any other conversion for the QCOW2 to handle. So if you are worried about the amount of disk that is used by the QCOW2 that you're downloading, then using a compressed QCOW2 is a very good option too.
Yeah, I thought it's still part of the QCOW2 format, but as far as right, because I actually had it on the next slide. But
okay, sorry, I jumped it.
when you go and do the conversion, there's a compress flag that you can specify, and it makes the conversion take a lot longer. I actually tried this stuff, and it's like sits there for a while. So, but it actually makes the resulting image be smaller. And then there's a set of links. This is actually something that Raghu had pulled together, saying, okay, here's a set of documents that say, okay, depending upon where I come from, if I've sort of tested my application on, VirtualBox or KVM or Zen or whatever, right? What do I actually do to convert that thing, right? I think that if I already have a VMDK, it's just the first line, right? Yeah. You just run Quemo image convert, and you get the QCOW2 out. But for these other ones, it's a few more steps to make sure that you're extracting the image out of the environment where you were first testing it. So these slides are already uploaded on where we put the other slides on the LF Edge wiki for Eve. So if you want to go follow these links, they're over there. I mean, it might make sense to make this stuff. I haven't thought about this before, but we can actually make this particular type of thing in the LF Edge wiki itself as well, so that people can actually contribute, saying, okay, I have some other recipe for how to construct images, right? So the community can contribute different ways of creating things. So maybe I should stop there before we get into best practice, or whether there's any questions so far in terms of the image creation and use. Okay, so best practices. So if you look at what are the things that you care about, and if people have sort of additional things in terms of what they think are requirements here, right, or things to consider, feel free to interject. But the things that we've seen is, having sort of sufficient flexibility so you can actually create variants, right? So that if you say, well, I have this thing that's mostly the same, but it's just a configuration difference, or it's the same OS, but it's a different application on top of that OS or whatever, right? That's one thing to think about in terms of how to structure things. And then the other one is the efficiency when you actually do updates. So if you want to, if there's an update to your base operating system, how does that roll out, and how frequently does that happen compared to you are improving your application, or you're changing the configuration of some particular device, right? How often does that happen, and what's the sort of process for that? And then the third thing that in some cases is a useful consideration is, okay, if I'm going to have multiple applications deployed on the same box, multiple virtual machines, well, do they have the same underlying, CentOS, Windows, Ubuntu, whatever OS? If so, I can actually save in terms of doing updates to those things, because I don't have to do them independently if I set things up to enable that sharing. So the recommendation based on this is to have applications use at least 4 volumes. So basically separating out more or less the unmodified operating system, and your Linux root file system, whatever, the Windows system disk, and then the configuration for your specific instance. This might be something that you craft yourself, right? Whether it's a separate disk that you can go and update. Is it per device? Is it per sort of deployment country, whatever type thing, right? Site. And this could either use the sort of Cloud-init support, where you can go and do this using support in the commercial controller for templating of what gets fed in as a Cloud-init user data, or it could be a volume that you just create, or content that you just create, just like any other content. And then the third one being your actual applications, it's binaries, data, binary and libraries, etc. And then the fourth thing is, if your application has some data that's long-lived, whether it's sort of preceded or whether it gets built up over time as the application is running, right? Keeping that on a separate, as a separate volume makes a lot of sense. In some cases, you might want to have that be an explicit volume so that it actually can be made to be persistent. It can have a life cycle that is longer and independent of the actual applications that are using it. And if you're, in addition to this, right, you can walk through what this actually does. It means that if I have a new version of the application, right, and it's 100 meg in size, but it's sitting in an operating system that's a gigabyte in size. Well, if I only need to update the application, that's the only thing that I touch here. If the configuration it's updated more often, well, that's typically a tiny volume that gets touched, right? So the amount of data that needs to be downloaded to different devices is small. And as I said, if you have 3 VMs running the same Linux distro or the same Windows release, well, keeping those separate means that you can decide that I'm going to update this one to run the new version, and it gets downloaded. It creates the content tree for that thing, and then as part of a purge workflow, for instance, you go and you use that application app instance A starts using that new content. And then later, a day later, a month later, you decide to roll app instance B to that new version. Well, it's already sitting there in the content tree from the first one. Right? So you have that version of the operating system. When the last app instance stops using that operating system version, well, then the content tree for it will actually be freed up. So that's an example of the benefits you get from this. Is there a question?
You have to lie.
Oh, I think you're not muted.
Not lie. You have to give the wrong date. They will fix it there because the system doesn't take it. System has not been updated.
DJ.
It is approved.
Sorry.
You're not muted.
Yes, sir.
Okay. So in addition, if you're using OCI content format, right, then you can also use layers to do even finer grain sort of construction of things on the fly, where if you construct the layers sort of with independent pieces being independent, and there's only one or a few layers that get updated. Well, those are the only ones that are actually end up being downloaded. So it's another gonna say it's another layer, but that's a bit silly. But it basically gives you another tool to basically manage the size of the amount of data that needs to get downloaded as part of moving between different versions. And the other, maybe I didn't say that, but if you deployed one app, right, that uses Ubuntu 18.04, and you want to deploy another one, if you structured it this way, it means that, well, that second one that also uses Ubuntu 18.4, it doesn't need to re-download the operating system because you already have that in that sort of more or less pristine form. So, questions about this? So in terms of how do you deal with sort of configuration and updates, right? I think I've sort of hinted at this a bit, but with the sort of purging things. But there is two ways, and this might not be the perfect use of these terms, but one of them is sort of the immutable infrastructure. Right? And immutable infrastructure is something that's common in sort of data centers and cloud deployments. Maybe more around containers, but it applies to VMs as well. Basically, the notion is that I have the bulk of all of the software I have is basically deployed, and you can think of it as basically being read-only. Right? I have an operating system, I have applications, whatever, right? And I just switch between version 1 to version 2 to version 3, etc. And basically the operating system and the applications and whatever, those parts of the content or the virtual disks or whatever do not self-modify. So I can just look at it and say, I know that I deployed this thing running Ubuntu 18.04. It's running exactly that build of Ubuntu 18.04 because that's what I deployed. The other way of saying it is that, well, no, I actually want to keep on using the existing mechanism for updating things. So I would have some way of doing self-update. So in case of Ubuntu, it can be that, okay, I just run normal Ubuntu and it does its automatic update, right? Windows update the same way that, yes, you have to figure out how to configure that stuff out of scope for this discussion. But basically, I start running Ubuntu 18.04 and it keeps on periodically checking with canonical, and it downloads and applies updates. And which means that I might get the updates there sooner, but now if I look at two different devices running the same app, the same version, well, they're not actually running identically the same thing because they have a different update history, right? And so they're self-modified. One can do this where you remain more in control by saying that, well, if you build your own control script, right? And I think Raghu has been, he's the proponent of this to sort of say, well, if you're going to do this stuff, make sure that you know what's going on, right? That you put some script in, like your config partition, for instance, and then or config volume, and then have this script check for, are there any, call home to you saying, are there any updates, any CVEs, anything else I should do, right? As part of typically as part of each boot of the app instance. So now you can get potentially a bit best of both worlds, that you can have this thing, and then you can say, well, I'm really going to move from 16.04 to 18.04 in the Ubuntu case. Okay, I will go and do the purge to move to that version. I have everything else stays the same, and this control script will then keep on applying CVs and other sort of changes as you go along. So that's the other part of sort of best practices from what we've seen to handle the life cycle of the volumes and the app instances. Any questions? So I mentioned Cloud-init. I don't actually know whether you guys have been using Cloud-init to configure things as you get started, but it's actually something that is very common with Linux, and it's actually available for Windows as well. It's typically used to configure things on first boot, but there are some hooks there to be able to go and do things on subsequent boots as well. And we've seen that as we work with partners that some network function virtualization, whatever, images, virtual appliances, they support this as well, but it's not, the standard isn't necessarily that nailed down. So this is actually an area where we're adding a bit more flexibility to deal with different formatting differences. But there is an open source sort of standard that describes how this stuff is actually should be used, how you can actually control things. So today, Eve creates a CD-ROM image from this. From the perspective of the API to Eve, there's some Cloud-init user data that's specified, and from the perspective of the Sedida commercial controller, it's something that you specify as a template that you can then go and refine with some variables, whatever, for each app instance. And then this gets fed to Eve, and the CD-ROM image gets created. And then as the application boots, it actually sees that CD-ROM image. There is work in progress in Eve to also serve this stuff using a standard URL for a linked local IPv4 address that is actually used in these Cloud-init deployment. So this is something that makes it possible to do some more dynamic update to this without having to recreate the CD-ROM image. But it's still in early stages in terms of determining how are people actually likely to use that stuff in the case of Eve. The other thing with the Cloud-init is the scripts that are running in the guest VM, they typically have hooks to resize the OS to the size of the virtual disk. So there's actually basically, if you're looking at QCOV2 here, where this applies, there's actually two layers of this. One is saying that I create a QCOV2 image, and it has some set of bits that are not 0, right? Which is, I don't know, 500 meg. And I specify when I created that this QCOV2 image has a maximum size of 2 gigabytes, which is just something that's recorded in the QCOV2 header. And then I upload this stuff to the cloud, right? And now I have something that if I go deploy it, it ends up with a root file system that is 2 gigabytes in size. Well, if I want to have variants of this, I might want to say, well, but wait, how can I create one that has a 10 gigabyte root file system image? And you could do that. You can take the same exact QCOV2 and you can tweak the maximum size, and you can upload that as a separate image. But you don't have to jump through those hoops. We can actually specify as part of deploying it that the size of this thing should actually be 10 gigabytes. And now Eve, before it boots the app instance, it basically says, okay, is the size that they specified larger than the max size of the QCOV2? If so, let's go increase the max size inside the QCOV2 to volume. So that's sort of one additional level of flexibility in terms of not having to create lots of different variant images that only differ in their maximum size. And then the other thing with Cloud-init is the way people typically use it. Yeah, there's sort of standard recipes for doing things for cloud deployments around setting up usernames, passwords, credentials, trusted SSH keys, whatever, right? Other certificates. But you can actually do arbitrary things in these Cloud-init scripts, like deploy, install additional packages, whatever. So one of the use cases for this is persistent, typically data volumes. And the common use case here is that people have some artifacts that you want to preload. I might have a bunch of data, sort of a database of things. In some use cases, you've seen this is basically firmware or images for other devices that are going to get deployed out at this site, right? So basically, have my firmware library for all of these things. It's just a huge amount of data, and if I always pre-install this stuff, it means I have it handy to basically have applications that can serve this content to other things out at this edge, out at this site. In the UI, as you go do this stuff, you identify it by some tag or name or whatever, and then this actually gets mapped in the API to Eve to a UUID. And as I said, these things have a life cycle that's independent of the actual applications, and they can be used by different app instances over time. If there's interest, you can actually explore, okay, in which cases, what is actually needed to do some level of sharing by multiple app instances at the same time, whether it's read-only, whether it is read-write sharing. But it requires a bit more sort of slightly different plumbing on the Eve side to make sure that you can actually do read-write sharing. And so that's one of the key use cases for this. And the other one is having some data volumes that are initially empty. So I'm going to collect a bunch of data and build up that data on the device, share some of it remotely with your cloud backend, whatever, your data center. But I need to have a large volume. Today, this is done by creating a QCOP2 image, which is effectively just the header, right? But it has some maximum size. And then you can actually go deploy this thing, and you specify, a content tree, a volume. You just go deploy using this. You can make it be a persistent one if you want to basically be able to delete that app instance, and that volume actually sticks around. But you don't have to do that. You can just make it be an implicit one as well. And right now this workflow is a bit complicated from the UI sort of reflects that we have all of these different layers with content trees and volumes and whatever, and it's possible to simplify that. So basically, you can say, just give me a blank volume of this size, and it will be provided to the application. What else? I think that was about it. So any questions? So I mean,
this was very useful. I think so. And yeah, a bunch of people were in different time zones. That we have a few people from India and Norway actually that couldn't join. So they will definitely be getting the videos.
Yeah, and some of the stuff that we talk about, since this is the open source project, right? There's a roadmap, and we're updating that roadmap as we go along based on interest and what people want to work on. Different parts of the community, but I think this is sort of the summary. Yes, it might look a bit overly complicated in terms of having all of these layers, but we found that we sort of need this flexibility to be able to deal with edge and minimizing the amount of things that need to get downloaded, etc. Okay, that was what I had. So any other questions? So as I said, these slides are already uploaded to the.
Yes, I guess you'll be sending the video recording later on.
Yeah.
Yeah, it'll be. We will attach the video recording, a link to it, along with the slides, so that it's in one package like what you sent out prior to the call.
Yeah, so it's on this LF Edge. The slides are here as well, so
Yep.
together with the other ones.
Okay, so I will stop recording now if there's no more questions.